how you doing? It's Coach Scott here. Let's do another one of our homework videos. And this is on worksheet 6B. Worksheet 6B. Let's look at question 3, and we'll probably get 4 in here on this video too. So this is the first time we're actually doing stoichiometry with gases. So some important things to remember. One mole of gas, whatever the gas is, has a volume of 22.4 liters. So let's look at this question. What volume of hydrogen gas is obtained when 23 grams of zinc metal reacts with an excess of dilute sulfuric acid at STP, standard temperature and pressure, which is 1 atmosphere, 0 degrees C, or 273 K. So let's make sure we have a balanced reaction, just like we do in stoichiometry. And it seems like we do. We have one zinc, two hydrogens, one sulfate. So now we're good. So let's go ahead and use dimensional analysis for this. So let's see what we started with. So it tells me I have 23 grams of hydrogen gas, H2 gas. Don't forget, hydrogen is always diatomic, or always H2. So let's put a little dot there for multiplication. So there's 1.0078 grams in one atom of hydrogen, but we have 2. So in 1 mole of hydrogen gas, we have 2.014 something grams of hydrogen, right? So next it asks for how many moles, and this is going to give me moles of hydrogen. Now, just like any stoichiometry, now is where the magic occurs. I've got to look at the balanced reaction, and it seems like, oh yes, cool. Oh, I messed up. It's not hydrogen gas. It's asking, we have zinc. So just ignore everything I just did there. Cross it out. So I have 23 grams of zinc metal. All right, so I'm going to have to look that up. So for 1 mole of zinc, I have how many grams of zinc? But I'm going to go ahead and set the problem up like we normally do in dimensional analysis, and we'll come back to it. So looking at the magic reaction, we're going to do our magic for every 1 mole of zinc. All right, I have 1 mole of hydrogen gas. All right, so if I have 1 mole of hydrogen gas, I have 22.4 liters of hydrogen gas. 22.4 liters of hydrogen gas. All right. So, looking up in my little periodic table, I see that zinc has a molar mass of 65.38 grams. 38 grams. So let's make sure we're doing everything right here. Okay, I started with moles, or grams rather, of zinc. So I can cancel out grams. Okay, I've got moles of zinc now. I can cancel that out. I've got moles of H2, and that's going to leave me with liters of H2. So let's get a little calculator here and see if we can get this sucker right. So, use my little calculator here. I'll get where y'all can see, hopefully. So I'm going to put in 23 divided by, let's see, 65.38. 38. Back up there. 0.38 times 1 divided by 1 times 22.4. And that gives me how many liters? 7.88 liters of gas. 7.88 liters of hydrogen gas. And if you look at the problem sheet, that's correct. All right, so we got that one down, right? We got number 3 down. So let's go ahead and start working on number 4. And again, this is a stoichiometry problem, but this makes it a little bit easier because, well, we only have to worry about 22.4 liters per volume of gas. So it asks us here, what volume of oxygen at standard temperature and pressure that tells me I can use 22.4 liters, is required to burn exactly 11.6 liters of methane according to this reaction. So I'm going to set up a little dimensional analysis. All right, I got 11.60 liters of methane, and it tells us what methane is, CH4. All right, so 1 mole of methane will have 22.4 liters. All right, now if we do our magic there and everything looks exact there, yeah, so it's balanced. I've got 1 carbon, 1 carbon. I've got 4 hydrogens, 4 hydrogens. Then I've got 4 oxygens on both sides. So we're balanced. So let's go to our magical molar ratio. So for every mole of methane, I'm going to consume 2 moles of oxygen. All right, so now we've got to do a little math there. So I got 11.6 and all that, and this comes, yeah, so far I can do it. So just like that other one, 1 mole of oxygen gas, just like the methane, contains 22.4 liters of oxygen. So let's start subbing out stuff and moving stuff out. Liters of methane, moles of methane, moles of O2. Oh, I'm ready to start calculating. So these are relatively easy. Get a little calculator here. Look. All right. So I've got 11.6 divided by. Oh, there's something wrong there. Back to calculate. Yeah, 11.6 divided by 22.4 times 2 times 22.4, and that's going to give me 23.2 liters. 23.2, I don't know if y'all can see that or not. 22.32 liters of gas.